Today we're gonna talk about the critical angle. The critical angle is only in the case where the light is going from a high to low index. So I will choose water, which is n equals 1.33, and I will go with the low as air, n is equal to 1. So my case is a light coming from water towards the air. In order to calculate what's the critical angle, let's start with small sketch so you can get it. This is the water and this is the air separation medium. As usual, the incident point, the normal, always the normal should be as dotted line because it's imaginary. I really don't know what's the incident angle here. The definition of a critical angle is when the light comes incident, but it does not really refract. It just goes directly on the surface of separation. In another meaning, the incident angle is not causing any refracted ray, but it has a total internal reflection. That means the refracted ray is typically on the surface of separation. What does that mean? That the theta r here is exactly 90 degrees. I'll take this idea or this notation and then I will start using Snell's law. So Snell's law says that Ni sine theta I is equal to Nr sine theta R. But the R here in this case is 90. So I will substitute instead of the theta R 90 degrees. I have a water and air medium, so the air is in Nr, the water is 1.33. And I really don't know what's the incident that caused this critical situation. So my unknown here today is theta I. I'm gonna call it in the second step theta C as critical angle. As you all know, sine 90 is exactly 1. Sine 90 is exactly 1. So all this phrase will change into just 1. 1.33 sine theta C is equal to 1. Divide by 1.33 both sides to keep the sign alone. Sine theta C is equal, by calculator, 1 divided by 1.33 is equal to 0.75. Shift sign to get the theta C. So I'm gonna use shift sign answer. Take the whole decimal together, so it's 48.75. 48.75 degrees or 48.8. So my critical angle is 48. Let's go back to the picture and understand what's going on.